In our lesson today, we're going to have an introduction to circles and the different parts of circles, and that's going to lead us to our overall goal for today is learning how to calculate the circumference of a circle. Before we talk about circumference, though, let's talk about what a circle is. A circle is a closed figure with all of its points an equal distance from its center. Okay, so you can imagine where the center of the circle is. Every single part that makes up the circle right here is the same distance away from the center of that circle. Now, there are a couple of different segments of circles that we need to know about. The first is going to be called a radius. A radius is any segment connecting the center to a point on the circle. Okay, and so we're going to draw a radius in our circle that we see here. So we imagine the center would be about here, and then I can draw a line segment in any direction. I decided to go over there, but I could have drawn it straight up, straight down, to the left, anywhere from the center. If I drew a line segment, this is what a radius looks like, and I'm going to abbreviate it R for radius. Another segment about circles that's important to know is called a diameter. A diameter is any segment that passes through the center and has both of its endpoints on the circle. Okay, so the radius starts at the center and lands on the circle. A diameter, though, is going to have both of its endpoints on the circle, and it needs to go through the center. So we can draw a diameter, maybe something that looks like that. Okay, and this segment right here is the diameter. And again, we can think about that as the letter D, D for diameter. Okay, so a radius, again, starts at the center and lands on the circle. The diameter starts and ends on the circle, and it passes through the middle. Explain the relationship between the radius and the diameter of a circle. Okay, so if I were to compare the radius to the diameter, the radius is half the diameter. Okay, since the radius goes from the center to a point on the circle, that would be half the amount of the diameter. So R is equal to the diameter divided by 2. Okay, vice versa, the diameter, there we go, is twice the radius. Okay, the length of the diameter is 2 times the length of the radius. So D, the diameter, is equal to 2 times R. So these are two very important formulas to know that relate the radius and the diameter. Radius is diameter divided by 2, half the diameter. Diameter equals 2 times the radius. In the chart, we're going to fill in the missing values of the radius and the diameter. If I know either the radius or the diameter, I'm going to figure out the other part that is missing. Okay, remember that the radius is half of the diameter, and the diameter is 2 times the radius. And so in our first example, they've told us here that the radius is equal to 12. We have to figure out what the diameter is. Well, remember right here, we said that the diameter is 2 times the radius. So we're going to take the value of the radius and multiply it by 2. When we do that, 12 times 2 equals 24. So if the radius is 12, the diameter would have to be 24. If the radius is 7.5, again, we're going to take that value and we're going to multiply it by 2. 7.5 times 2 equals 15. So the radius is 7.5, the diameter is 15. If the radius is 36, again, just multiply the radius by 2. 36 times 2 is 72. So when the radius is 36, the diameter equals 72. In the next 3 spots, though, they tell us the value of the diameter. We have to figure out how much the radius is going to be. Remember, the radius, to do that measurement, you take the diameter and you divide it by 2. So if the diameter is 50, I'm going to divide that number by 2 to get the radius. 50 divided by 2 means that the radius would have to be 25. If the radius, if the diameter is 76, again, just take that number and divide it by 2. 76 divided by 2 is equal to 38 for the radius. And if the diameter is 91, to get the radius, take 91 and divide it by 2. 91 divided by 2 means that the radius would have to be 45 and 5/10. Our objective for today's lesson is to be able to calculate the circumference of a circle. So now we need to discuss what circumference is. Circumference is the distance around a circle. Okay, circumference is the distance around a circle. And so if I take a look at my circle again, if I want to go around this circle, I'm calculating the circumference. Okay, so I'm going to label that here, the circumference. Again, that's the distance all the way around the circle. Okay, and that's what we're going to be practicing today, finding the circumference of a circle. Now, in order to help us calculate the circumference, there's a very important number in math that we have to familiarize ourselves with, and that would be the number called pi. If you measure around a circle, so the circumference, and you divide it by the diameter of the circle, you will always come close to the approximate value of pi, okay? Pi, in order to calculate that, you take the circumference and you divide it by the diameter of the circle, okay? On your scientific calculator, you should have a button that looks like that, and if you push that, that number is what the approximate value of pi is. So if you punch that onto your calculator, pi is approximately 3 and 1/4,159,2654. Okay? Pi is a number that goes on forever and doesn't repeat. We call that an irrational number. Okay? These are the digits of pi that we are going to use. That's the full calculator display. And again, that's going to be a very important number for us to know when we're working with circumference. Okay? So, in order to calculate the circumference, there are actually two different formulas that we are going to need to know. Remember that the circumference divided by the diameter is equal to pi, okay? So if I know the diameter of the circle and I want to figure out what the circumference is, all I would have to do is take that number pi and multiply it by the diameter, okay? One of your circumference formulas is C equals pi d. Circumference equals pi times the diameter. Now, if instead they gave you the radius of the circle, there's a different formula that we would have to use. Now remember that the diameter is 2 times the radius, okay? So if instead of knowing the diameter, all right, if they gave me the radius, I'm going to have to replace d with 2r because the diameter is the same as 2 times the radius. So if they give us the radius of the circle, this equation now is going to change to C equals 2 times pi times r. And again, that 2r is the same as that diameter right there. So put it like a little star next to each one of these formulas. If you know the diameter, use C equals pi d. If you know the radius of the circle and you want to know the circumference, use C equals 2 pi r. In the next part of our lesson, we're going to look at the volume of prisms. Okay, surface area in the first part of the lesson dealt with the outside surfaces of the solid. Volume of a solid is going to deal with how much space is on the inside of the solid. And in order to help us calculate the volume of a prism, we're going to use this equation right here. V equals capital B times H. All right, capital B equals the area of the base. So we need to make sure that we know our area formulas. H is going to be the height of the prism. The height is always the measure from one base to the other base. Volume is measured in cubes, so our units will always be raised to the third power whenever we do a volume question. Okay, so again, to calculate the volume of a prism, we have to do the area of the base multiplied by the height. If we're working with a square prism, okay, also known as a cube, I'll try to draw a picture of a cube. it looks something like this. We know that a cube has dimensions called the length, the width, and the height. Okay, to get the measurement of this base down here, I have to do the length times the width. So to get the volume, I'm just going to do the length times the width and then multiply it by the height. So volume equals length times width times height for a square prism. A square prism, a cube, is just a special rectangular prism. So the rectangular prism is also going to be length times width times height. All right, a triangular prism is just going to be a little bit different. So I'll try to sketch my best triangular prism. Okay, if I draw something that looks like this right here. Okay, now we set up here that the height is always what connects the one base to the other. But when our triangular prism looks like this measurement that connects the two triangles together is actually going to be the length, which is why here in our formula, it doesn't say h anymore, it says times the length. All right, we need to figure out what the area of a triangular face is, and then multiply that by the length to get the volume of the triangular prism. To get the area of a triangle, we know that we have to do 1/2 the base times the height. So on this triangle right here, remember, this can be the base, and the height has to be perpendicular to that. In our next example, we're going to find the volume of the rectangular prism. The rectangular prism measures 11 meters by 3 meters by 7 meters. In order to find the volume, I again use the formula V equals capital B, which is the area of the base, multiplied by the height. And remember, we said back up here to find the area of a rectangular prism's base, we just do the length times the width. So the formula is really just length times width times height. Length times width times height. So V equals, okay, well, I can call 11 meters the length, 3 meters the width, and 7 meters the height. All I need to do then is 11 times 3 times 7, the length times the width times the height. Okay, multiplying here, 11 times 3, that's going to be 33. And then I just have to do 33 times 7, which is going to equal 231. Now the units are meters, and then back up here we said it's measured in cubes, so it's going to be meters cubed, or meters to the third power. 231 cubic meters is the volume of that rectangular prism. In the next section, we're going to look at volume of trapezoidal prisms. A trapezoidal prism is a prism where the base shapes are trapezoids. And just like finding the volume of a triangular prism, when we find the volume of a trapezoidal prism, at the end, we're going to have to multiply by the segment that connects the two trapezoids together, which in this case is going to be the length. Okay, so that's going to be at the end of my volume formula. To calculate the area of the base, the capital B, well, I need to know the area formula for a trapezoid, and fortunately I do. To find the volume of a trapezoid, I do 1/2 the sum of the bases of the trapezoid, base 1 plus base 2, multiplied by the height. Okay, remember that the bases on the trapezoid are the two parallel sides, so that's going to be base 1 and that can be base 2. The height is perpendicular to both of those. Okay, so that would be the area of one of the trapezoids, and then to get the volume at the end, I just have to multiply by L, the length. So this is the formula that you would use to find the volume of a trapezoidal prism. Let's use that now to answer this question underneath. A watering trough is in the form of a trapezoidal prism. Its ends have the dimensions shown. So we're going to use the dimensions in this picture. How long is the trough if it holds 12 cubic meters of water? All right, well, I have a couple of clues here that this must be a volume question because they're talking about holding water, which means the water's inside of the trough. And it also gave the units in cubic meters, which I know is volume. So I'm going to use this volume formula. V equals 1/2 base 1 plus base 2 multiplied by the height multiplied by the length. Now I'm going to substitute in values that I know. I'm going to have my 1/2 here. If I look at my trapezoid, I see it has bases of 1 and 6/10 and 2 and 4/10. So I'll do 1 and 6/10 plus 2 and 4/10. It has a height right here of 1 and 2/10. And then L, how long is it? That's actually what I'm trying to calculate, which means they must have given me the volume. And that's actually what they told us right here. It holds 12 cubic meters of water. That's the volume. Okay, so to get the value of L, the length, we're going to actually use our order of operations by adding what's in the parentheses to start. 12 equals 1/2 times 1 and 6/10 plus 2 and 4/10. Well, that's just 4 times 1 and 2/10 times L. Well, half of 4 is 2, so 12 equals 2 times 1 and 2/10 times L. And I'm just going to bring that up over here. Okay, so 12 equals 2 times 1 and 2/10 times L. Well, if I multiply 2 times 1 and 2/10, that equals 2 and 4/10. 12 equals 2 and 4/10 times L. So to get the value of L, the length, I'm going to have to divide each side by 2 and 4/10. On the right, that leaves us with L. And on the left, if I do 12 divided by 2 and 4/10, I get 5. So this means that the length is 5 meters. Okay, we didn't find an area, a surface area, or a volume, so the unit is just the given unit that we saw in the picture, which was meters. The length of the trough was 5 meters. Next, we're going to calculate the volume of a triangular prism. Our formula for that, again, is V equals 1/2 the base times the height times the length. The base times the height, that comes straight from the triangular face. And again, the length is what connects the two triangles together. So this segment right here is going to be the length. Okay, this right here, the base and the height have to be perpendicular to each other. Okay, and then all I have to do is multiply those values together. So V equals 1/2 times, okay, well, B equals 7 centimeters, so I know that's 7. H equals 9 centimeters, so that's 9 centimeters right there. And then it gives me P and S. P and S are the two slanted sides of the triangle that aren't the base. So I can call that one P right there, which happens to be 11.5 centimeters. And I can call this one S right here, which happens to be 11 centimeters. Now, neither one of these are needed for this formula because the base and the height have to be perpendicular to each other. And then I need the length, which connects the two triangles together right here, is 15 centimeters. So let's substitute in these values. 1/2 times the base they said was 7, times the height right here they said was 9 centimeters, times the length was 15 centimeters. Okay, well, I can do 1/2 times 7 times 9 times 15. 7 times 9 I know is 63. 63 times 15 comes out to be 945. So now all I have to do is find half of that number, and that gives me a volume of 472 and 5/10. And now the units, again, were centimeters cubed. 472.5 cubic centimeters is the volume of our prism. In the next part of our lesson, we're going to look at the volume of composite prisms. Remember that volume deals with the amount of space on the inside. Our first example says to find the volume of the following three-dimensional object composed of two right rectangular prisms. Okay, we can see here we've got a smaller rectangular prism stacked on top of this larger rectangular prism. We need to find the volume. Okay, so just like we did with our surface area problems, we're going to break this up into two different solids. I'll find their volumes, and then once I know both of those, at the end I can just add them together. So why don't we start with this, I'll call it the top rectangular prism. Okay, for a rectangular prism, to find its volume, remember that you have to find the area of the base and then multiply it by the height.
To get the area of the base, you multiply the length by the width. So really our volume formula is length times width times height. Looking at this top prism, okay, this length measurement right here is the same as this, so that's 4 meters, times the width right here is the same as this, which is going to be 5 meters, and the height here I can see is 5 meters. So I'm going to do 4 times 5 times 5. 5 times 5 is 25, times 4 is 100 meters cubed for volume. Remember to cube the units. Now I'm going to look at the bottom prism. It's also a rectangular prism, so my volume formula once again is going to be length times width times height. And for the width, or for the length and the width, I should say, I need to figure out what these measurements are. This entire measurement and this entire measurement right here. So let's start with the length. Okay, I know this measurement is the same as this measurement, which is the same as what we would have in the back here. Now I can see this segment here is 6 meters. So if I extend this from here to here is 6 meters. I need to figure out how much this measurement is. Well, this segment is the same as this segment, which we said before was the same as this segment. So this is 4 meters. So 4 meters and 6 meters makes a total of 10 meters for the length. For the width, it's going to be something similar. I need to know this measurement, which is the same as this measurement, and that's going to be the same as this entire measurement. Now I can see this is 5 meters, so if I extend this over from here to here, that's 5 meters. And I need to know this measurement here, which is going to be the same as this measurement, which matches what we have here. This is also 5 meters. So 5 meters and 5 meters makes a total of 10 meters for the width. The height of this bottom prism is simple. That's just 3 meters. And so we'll multiply 10 by 10 by 3. 10 times 10 is 100. Times 3 is 300 cubic meters. And now for the total volume, all we're going to do is add them together. 100 plus 300 makes 400 cubic meters for the volume. In example number 2, they ask us to find the volume of the following three-dimensional figure composed of two right rectangular prisms. Okay, so this time we have a rectangular prism that's in the front, and it's attached to a rectangular prism there in the back. And just like with the last example, I'm going to want to find each of their volumes, and then I can find the total volume by adding at the end. So why don't we start with this front prism? It's rectangular, so our volume formula is going to be length times width times height. And so I can see right here that it has a length of 6 inches. It has a width of 2 inches. And for the height of this prism in front is the same as the height of the prism in the back, which I can see right here is 9 inches. And so all I have to do is multiply 6 by 2 by 9. 6 times 2 is 12, and 12 times 9 gives us 108 cubic inches. Now I'm going to do something similar for the back prism. That as well is a rectangular prism, so the volume formula, volume equals length times width times height. And for the dimensions, it has a length here of 10 inches, a width of 2 inches, and the height we discussed earlier was 9 inches. 10 times 2 is 20. 20 times 9 is 180 cubic inches. And once again, to get the total volume this time, we will add 108 with 180, which gives us 288 inches cubed for the total volume. In our next example, we have a triangular prism, and it has a hole cut out of it that's also in the shape of a smaller triangular prism. They want us to figure out what the volume of the prism, the big triangular prism, would be once we cut out that hole. All right, so we're going to start by finding the volume of the big triangular prism. Okay, that would represent the total volume of the full shape, and then we'll deal with the hole in just a minute. For a triangular prism, the volume formula is just 1/2 of the length times the width times the height. So we're going to have 1/2. Now, the length of a triangular prism is the segment that connects the two triangles together. In this case, that's this segment right here, which I can see is 4.5 centimeters. I'm going to change that into decimal form, 4 5/10 for the length. For the width and the height, those need to come from the triangular face, and remember that they need to be perpendicular to each other. So I'm looking to see where the width and the height form a right angle. And I can see that this segment and this segment right here form a right angle. So I can use the values of 4 centimeters and 3 centimeters, because that's what this measures back here, 3 centimeters, as my width and my height. So 4.5 was the length, 4 centimeters can be the width, and the height here can be the 3 centimeters. If we go ahead and multiply here, we're going to have 4 times 3 is 12. Okay, so we're going to have half of 12 times 4.5. And I know half of 12 is 6. So I just have to do 6 times 4.5. And that's going to give me 27 cubic centimeters as the volume. Now I have to figure out the volume of the hole. And the hole is in the shape of a smaller triangular prism. So now let's do a small triangular prism. And not get in the way of the big triangular prism. Volume formula again is going to be 1/2 the length times the width times the height. And again, I'm going to have 1/2 times. Now the length, again, connects the front triangular prism with the back triangular prism. This hole starts on the front triangle and goes all the way back to the back triangle. So the length is still going to be 4.5 centimeters. For the width and the height, again, I'm looking for where that's perpendicular on the small triangle. And that's here where it's 2 centimeters by 1.5 centimeters. Those are perpendicular to each other. So I can use 2 centimeters for the width, 1.5 centimeters, 1 5/10 centimeters for the height. If I multiply here, 1/2 times 2 is just 1. So I'm just going to have 4.5 times 1.5 that I need to multiply together. And if I multiply 4.5 by 1.5, that gives me 6 75/100 cubic centimeters as the volume. Now, in order to get the total volume, this time, because there's been a hole that was cut out of the solid, I'm going to take the entire volume, 27, and subtract out what was cut out, in this case, 6 75/100 centimeters, cubic centimeters. And that's going to leave me with a total volume of 20 25/100 cubic centimeters as the total volume. Okay, when there's a hole cut out, you have to do a subtraction at the end to get the total volume. In example 5, we're once again dealing with a solid that has had a hole cut out of it. A square hole with side lengths of 4 inches is drilled through the cube. Determine the volume. Okay, so we see here that we're working with a cube. That means the length, the width, and the height are all the same measurements. They're all 12 inches. There's been a square hole cut out where each side of this square hole is 4 inches. So that's 4 inches, that's 4 inches, and it goes all the way through the cube. We're going to try to figure out what the volume of the cube is after the hole has been cut out. So let's imagine that it was a whole cube to start. In order to find the volume of a cube, volume equals length times width times height. And in this case, when we look at that, well, all of them are 12 inches. So it's going to be 12 times 12 times 12. Okay, so we just have to multiply 12 by 12 by 12. And that's going to give us 1,728 inches cubed. So that would be the volume of the cube if there wasn't a hole in it. Now we have to account for that square hole. Okay, well, if we think about this hole, that's going all the way through to the bottom here. Okay, so if we imagine that, okay, that's in the shape of a rectangular prism. And in order to find the volume of what has been cut out for a rectangular prism, I'm again going to do length times width times height. For the length and the width, they told me that it's 4 inches by 4 inches. This was a square hole, 4 by 4. And for the height, it goes all the way through the cube, so that has to be the same height as the cube, which was 12 inches. And so we're going to multiply 4 by 4 by 12 in order to find the volume of the hole that was cut out. And that gives us 192 cubic inches. Now to get the total volume, which is the cube with the hole taken out of it, once again, we're going to take the entire volume and subtract out the hole. And if we do 1,728 minus 192, that's going to leave us with a total volume of 1,536 cubic inches.